Gravity in Planets and Space. Chapter 1. Unraveling the Mystical Gravitational Force. Gravity is one of those things we all experience but seldom actually think about. It's that invisible force keeping you grounded, stopping you from floating off into the vast expanse of space. But what is gravity really? Well, according to Sir Isaac Newton, gravity is a force of attraction that exists between any two masses, any two bodies, any two particles. To illustrate this, imagine you're sitting on top of a hill with a football. You give the football a slight nudge. What happens? It rolls down the hill, right? This is gravity in action. The force of gravity is pulling the ball towards the center of the Earth. Now let's take this a step further. Imagine you're standing on the moon holding that same football. If you were to drop it, the ball would fall to the ground, but much slower than on Earth. This is because the moon is smaller and has less mass than Earth, so its gravitational pull is weaker. Chapter 2. A deeper dive into space's gravitational force. Gravity isn't just about what happens on Earth, though. It's the force responsible for the existence and behavior of everything in the universe. The same gravitational force that makes the football roll down the hill also keeps the moon orbiting around the Earth, and the Earth orbiting around the sun. Think about our own solar system. All planets, including Earth, are being pulled toward the sun due to its massive gravitational pull. Yet we're not plummeting into the sun. Why? Well, it's all about balance. Even though the sun's gravity is pulling us towards it, Earth is also moving sideways fast enough to avoid falling in. This delicate balance between forward motion and gravitational pull creates an orbit. It's like a constant game of cosmic tag, where gravity is always it, and Earth is always just out of reach. Chapter 3. Navigating through the gravitational challenges. While gravity is fundamental to our existence, it also presents challenges, especially when we venture into space. For astronauts, understanding and adapting to different gravitational conditions is crucial. Astronauts in space experience microgravity, a state of free fall creating the feeling of weightlessness. This has several effects on the human body, from muscle and bone loss to changes in bodily fluids, which can result in vision changes. On Mars, the gravity is about 38% of that on Earth. This means astronauts would have to adapt to moving in an environment where they're much lighter than they're used to. Understanding gravity isn't just about satisfying our curiosity. It's also essential for practical applications, like designing spacecraft and predicting their orbits, planning space missions, and even improving technologies here on Earth. So, the next time you see a ball rolling down a hill or look up at the moon in the night sky, take a moment to appreciate the incredible and complex dance of gravity that makes all these ordinary miracles possible. If you're enjoying this journey through the cosmos with me, don't forget to subscribe and join our crew of space explorers. There's so much more to discover. Let's explore the universe together.